it's my great pleasure in inviting you all for the seminar on higher education and career opportunities in software engineering in USA. Now I would like to request Dr. Shashikant Albal, Director, SSN School of Advanced Software Engineering, to set the theme for today's seminar.
Yeah. Good afternoon, everyone, and I would like to welcome all of you to this unique seminar on higher education and career in USA, and especially in the field of software engineering. And this seminar would be conducted by Professor Matthew Bass, who has come all the way from CMU. You want both? Who has come all the way from CMU to conduct this seminar. So I would like to welcome Professor Matthew Bass, who has come all the way to conduct this seminar, and hearty welcome to all of you. As you are all aware that SSN School of Advanced Software Engineering is the longest international partner of Carnegie Mellon University in the field of software engineering. We have been offering this program jointly right from 2001, and now we have also planned to extend to offer some certificate programs in the emerging areas in the field of software engineering. Like recently, Professor Matthew Bass conducted one workshop in cognizant technology on architecting data intensive scalable system. So there is a lot of demand, like the software engineering field itself is changing every now and then, and keeping in tune to the industry demand, along with offering a full-fledged master's degree program. This is a full-fledged master's degree program wherein the students do 2 semesters at SSN and then proceed to Carnegie Mellon University and complete the remaining part of the 2 semesters program in Carnegie Mellon University and get the degree from proper Carnegie Mellon University. And you may ask, what is the benefit of this program? The benefit of this program is more learning. Anyway, I'm sure we are all eager to listen to Professor Matthew Bass. So we'll tell more about the program and all those details at a later stage. I'm very happy to hand over to Professor Matthew Bass, who will enlighten us on career, how to develop career and higher education and career in USA, especially in the field of software engineering. Thank you.
I request Professor Matthew Bass to take over from you.
Thank you. So good afternoon. Thanks for coming and spending a few minutes to listen to what I have to say. So this morning, Dr. Albal was introducing the program that we had this morning, and he used words like eminent and distinguished. And I was looking around trying to figure out who he was talking about, and then he introduced me, which was a little bit of a surprise. And so I requested a copy of the videotape only because I'm sure my wife would never believe that someone was talking about me in the context of eminent and distinguished. And so I was waiting for the eminent and distinguished again this afternoon, but we forgot that part, I guess. All right, so I'm going to talk a little bit about the software engineering, the professional software engineering programs that we have at Carnegie Mellon and that we have here at SSN. As Dr. Albal said, this is a collaboration that we've had since 2001. What I'd like to do is talk a little bit about what software engineering is and distinguish that from computer science. Talk a little bit about the focus of software engineering. I'll talk a little bit about some careers in software engineering, and then we'll go into the professional program itself. Talk about the structure of the program and a little bit about the structure of the interaction, and then probably get to what most of you are interested in. What kinds of jobs do people get? What sort of salaries do they have they been getting, and that sort of thing. So, how many people have some work experience? Okay, small number. Does anyone know anything about performance engineering? Has anybody worked in an environment where people are going to evaluate software with respect to its performance characteristics? No? Well, if we look at the way software is typically developed today, often what happens is we're going to design the software, we're going to build the software, and then we're going to test the software. And we're going to test it from a variety of different perspectives. When we talk about things like performance engineering, for example, this often comes into play after the software is developed. And so again, we design, we build the software, and then we test it with respect to performance. Does it respond in a timely manner? Does it support the sort of load that we anticipate? If it doesn't, then we try to tune the software. Often this means that we try to tune the database in order to improve the performance, in order to improve the throughput. So this is what you typically see in software today, software development. If we apply the same sort of concepts to other engineering disciplines, then this starts to look a little strange. So imagine that we were going to do something like this if we were building a bridge. So we build a bridge, we design the bridge, we build the bridge, and then we test it with respect to things like load. How do we do that? Well, we drive a train across the bridge to determine whether it supports the requisite load. If it doesn't, what happens? Well, the bridge breaks. We now need to go back and rebuild the bridge. This doesn't make a lot of sense from an engineering perspective. What we do when we're looking at other engineering disciplines is we'll design the bridge, we'll then analyze that design with respect to its intended use. So we'll determine what sort of load that particular design would support. What kind of flex would we have in the bridge? What would the impact of wind shear be, and so forth. And we'll compare that with the requirements. If it's sufficient, then we go ahead and build the bridge. If it's not sufficient, then we're going to have to modify the design. And we do this prior to construction. This is what engineering is all about. Engineering is about being able to predict the results prior to construction, being able to develop models and analyze models and determine whether they meet our needs from a variety of perspectives. This is very similar in software. So rather than designing and building prior to understanding what it is that you're going to get, ideally we'd be able to predict prior to construction what sort of properties would result. In that way, we can determine whether the design we have is suitable for its intended purpose. If we look at the sort of software that we're building today, the amount of effort that it takes, the amount of upfront capital investment that's required in order to build the software, it really doesn't make sense to build it prior to knowing what sort of results we're going to get. We want to be able to analyze the design. We want to be able to predict prior to construction what sort of load the system will support, how long it will take to modify or vary the software in a variety of perspectives. What will happen if we have some sort of fault or failure in the software or in the hardware that's required in order to run the software during execution, and so on. And so in order to do this with respect to very simple systems, this is not so difficult. So if we look at a very simple structure, we can look at this structure, we can anticipate what sort of materials would be required. We can think through the steps required to build that. We can use rules of thumb to figure out what sort of dimensions we need in the supporting structures and so forth. This is not very complicated. This is something that we can keep in our head. and we can manage without any complicated or sophisticated models. Excuse me. But as soon as we get to much more larger and complex systems, those ad hoc approaches start to break down. So we would never imagine building a skyscraper without being able to determine what sort of load the foundation would support. Again, what's the impact of wind shear? What's the impact of vibration in the event of an earthquake? And so forth. And so today with software, we might be building software with tens, hundreds, or even thousands of people. We're going to invest millions or maybe even billions of dollars in the upfront capital investment. We want to know that that investment is going to yield a return. We want to know that it's going to be able to support the number of users that we anticipate. We want to know that we can build it. We want to be able to predict the number of people required to build the software. We want to be able to understand the sort of coordination that's needed amongst the individuals that are going to build the software and so forth. When we start to talk about the models and the techniques to do these kinds of things, this is when we're talking about software engineering as opposed to computer science. So computer science is going to teach us something about how the software executes on the hardware. It'll teach us some principles of operating systems, principles of programming languages, and so forth. That's certainly sufficient knowledge to build a simple software system. If we go back to our earlier image, to build a software system that maybe is analogous to this sort of structure. But it's not sufficient to build a very complex and large software system that might require coordination amongst many people, that's going to be critical from a business perspective, that's going to have to handle hundreds or thousands or millions of transactions a second. It's going to be dealing with very large volumes of data, that needs to operate 24/7, that needs to support live upgrade and so on. So if we're going to build complicated systems, we need some additional techniques. This is the focus of the professional software engineering program. This is where software engineering comes into play. This is where you need some additional knowledge and additional techniques. So you guys can stop me and ask questions at any point if you want. So what is it that you do with this knowledge after you graduate? So there are many potential options. What I'm going to do is talk about a few different categories of organizations and the associated career opportunities that you might find in these different organizations. So I'll talk a little bit about the characteristics of the organizations and how that context gives rise to different sort of needs, and then how career paths will kind of align with those needs. So if we look at what I'm calling product-oriented companies, these are organizations that generate revenue from the sale of software products or software-intensive products. So if we think about software products, this is actually an area that is shrinking. So we used to have a lot of products that you would download, or you would buy the disk. You would get the media in one form or another and install on your local device. And so we can think about things like the Microsoft Office suite prior to Office 365. Maybe Adobe and so forth. These are purely software systems, or software products rather. This is an area that's moving much more towards software as a service. So when we look at things that we used to install on our local system, we're now hosting those, and so they have very different characteristics. But we still have a lot of software-intensive devices. So these are things like cell phones, TVs, refrigerators, automobiles, ultrasound systems, and so forth. So these organizations are again, they're going to make revenue from the